How's it going? This is Tim here. I hope you're doing well. I'm in the mood to make a video. I've never really, I have lots of SolidWorks, how to use it, but I don't have enough design videos of, I feel like there'd be some benefit if I let you into my head and kind of follow along how my head designs things. So one of the things I want to work on is I teach a mechanical systems class at the community college, and I'd like the students to. I'd like to be able to hand out some gearboxes, cheap ones that they can disassemble, and they can kind of see how they're assembled with bearings and shafts. And I don't want to spend a fortune on them, so I'm thinking a lot of the parts we could just 3D print them. And we could probably 3D print all the parts really, but I'm thinking the gears themselves, the housing, the knob even, we will just 3D print, and then maybe just the shafts and the bearings, we would make them out of metal, and just buy them. I'm going to yeah I'm going to do it in inches because I'm used to that. So forgive me, but we're just going to stick in inches, and I'm gonna let you in, kind of. So yeah, I'm gonna work through this, and I'm gonna kind of think about. And I haven't really thought about this very much, so it's going to be pretty raw. But I'm thinking I'm gonna have a knob to turn the bloody thing. I'm gonna have some bearings. I'm gonna have some gears, and let them have a little, maybe have not an enclosure, but maybe have an enclosure with like one wall taken out so they can actually see what's going on inside. So let's look up McMaster Car. Now this is a great website. It's a great company when you're spending someone else's money, but you can get all the models here. You can see what's available. But when if you're spending your own money, find what you like here, but then purchase it on Amazon.com. I know, I'm not a fan of Jeff Bezos, but look, that's the cheapest way, unfortunately. All right, so let's have a look at. I'm going to type in gears, and I think we're going to use a worm and a worm gear. So this I'd like to, the smallest ones they have are quite large, but that's okay. The bigger they are, the easier they are going to be to print. So we're just going to get a worm that is a half an inch, and this lad will do the job right away. This is just fine. It has a keyway on it, and let's just download that. Let's try it again. There it goes. Now why can't I? I'm getting used to this new computer here. This is my work computer. Downloads, open. All right. I'm just going to copy that and put it in here. All right. And right, let's go back. So this is a gear pitch of 12. So I'm going to go worm gear. Inch for shaft diameter, half an inch. I like keyed. How many teeth? No, we don't want a worm. We want a worm gear. What's going on here? No, I don't want a worm. I want the gear. Let's do 20 to 1. What about 10 to 1? Maybe a bit smaller. Shaft diameter, awesome. It's in bloody millimeters. Inch worm gears. Gear, how big is it? Outer diameter, that's fine. We could use this one here. Let's have a look at it. Product detail. Yeah, that'll be fine. What size is it? Outer diameter, it's roughly 2 inches. Perfect. Look at that expense. $97 for a little gear. Big money. All right, let's get that out of there and put it in Gearbox idea. Okay, so we got that. What else do we need? We're going to need a knob. Let me just make sure that is a half an inch. Okay, we need a knob. And we want a knob that has a threaded hole. I want a knob that has, yeah, this will be fine. I'll just have to modify it and put a set screw in there. So we'll do something like this, hole diameter 1/2 inch, head diameter 2 inches. This is fine. And look, like a black oxide, a knob isn't that expensive. I wonder if I bought one that had a set screw. Can I buy one that has a set screw? We want one that has a hole and just has a simple set screw. I don't want to have to. I don't want to have to drill it out. Maybe I will have to do. Look, that'll do. We'll just make it work. A 1/2 inch head diameter, 2 inches. Let's just go with this one here. All right. Now, it's 1/2 inch. Lovely. Let's download that and let's just move it in. So we got the knob. We got the gears. We need the shaft. We're gonna have to have bearings. Now, bearings. I want bearings. I want bearings that are a flange bearing, and I want a bearing that has the inner raceway that kicks out. So we're just going to go inch. The shaft diameter is going to be a 1/2 inch. I like this set screw collar. Look, lovely, lovely. This is what we want. It has a flange and it has the collar sticking out. You'll see why this is useful. I want the flange. Yeah, this is a nice bearing, but we're going to buy. Let's see if I can buy this in Amazon. Expensive enough. Too expensive for what I want. Let's see if I can get a 1/2 inch bearing. Bearing ID 0.5. I want it, there you go. I want it flanged for sure. We have a flange here, but I wish the outer raceway protruded. It makes it easier when you want to assemble. Let me have a look at this one here. The side. They used to provide you with CAD files. And how much are these bearings, first of all? Oh, they're cheap. Now, IED is 3/4. That kind of sucks. I wonder could I just use bushings? That's what I'll do, but they're not gonna. I think let's just use bushings for the job. Bearing ID flanged, 0.5. Bushings are going to be cheaper. Oh yeah, there you go. Now what is this? A 1/2 inch by 3/4 by 1 by 1.5. Yeah, this is what we want. We just want bushings. And they'll be able to see. I could push them in. I could press them in myself, and then they won't have to mess with them. All right, let's go back here to McMaster Car, and we'll find ones. And whatever we find in McMaster Car, we will. Now I want flange bushings. I'll be able to find them in Amazon. I don't want flange drill bushings. I'm just gonna go with bushings. Plain bearings. Shaft diameter a 1/2 inch. Inch. They could be made out of plastic just fine. This thing is not going to be carrying a whole lot. It's not going to be carrying any load. Oil embedded flanged sleeve bearings for housing ID. We can make that whatever we want. Maybe 5/8. Look at that, lovely. Let's just download this. That's too short. What is that length? What is the length? Just looking for it here. The total length is a half an inch. Let's just go with this for the time being. We can always change it if we have to. Okay. I'm having to do this all in one monitor, which makes it a bit challenging for me. All right, and then what I'm going to do is I'm going to go shafts, and I'm just going to get a piece of half an inch shaft, a deep profile would be nice. And we can go with, is there stainless steel? Yeah, the other stuff rust. Look at this. Look at this tolerance is nice. It's no bigger than a half an inch, and it's going to be 3 thousandths less. So it should fit into those bushings, no problem. So let's download that. So what do we have? We have do we have everything? All right. So I'm going to close that down, and I'm going to open up an assembly. I'm actually going to show you some stuff. If you've been watching my videos, I don't think I've ever shown you before, and it's it's how to design, or it's how to do maybe an assembly design. So gearbox idea, I'm going to just highlight them all, and I'm going to just go open. One, two, three, four, five. All right, that seems. Anyway, yeah, that might work. I feel like we want this to be a little bit longer. Um. All right. Um. Now, I suppose I'm going to create a new part before I do this. And I'm just going to create a box, literally like a box to start with. And I'm just going to go top plane, and I'm going to go center rectangle, and let's put this in inches. Now, what is that? That's about 4 inches. Let me get the calipers out. Um, so I can kind of get a feel. 4 inches is about right. Four, 4 by 4, and I'm going to do another box, and let's make this a half an inch, and let's extrude this, the whole thing, and we'll make it blind. Let's make it 3/8 0.375, and then I'm going to go and hit this sketch again, and I'm going to hit extrude, and I'm going to make this 1.5. Look, that's a start. I'm going to save this, and I'm going to call this Gearbox Housing. Now, I'm going to right click on this metal gear, and I'm just going to move these out of the way, and I'm going to go insert Gearbox Housing, and I'm just going to go OK, right? And if I go OK, notice how the assembly planes are right bang in the middle of that thing. Now, I need, so this is what I'm going to show you. This is what I'm going to show you. Let's, I'm going to write, even though, let's save this first of all. And what will we call it? Gearbox Housing. I'm in an assembly right now. I'm going to right click on this, and I'm going to hit this. Now, what's going on here? I'm going to right click on this. Why is this? Okay, let's just drop this down so you can see it better. Here we go. Right click. What? Why? Is there something that's getting in the way of my? How do I get rid of this bloody thing? Unpin the connection bar. Can I move? Can I move that? No, I wanna. Stop. It's hiding. It's hiding some commands up here that you can't see. Maybe you can see them. Okay, let's try this again. If I right click, well, that's annoying. Oh, that's annoying. If I click here and I just go edit component, yeah, that'll have to do. There it is anyway. I click it, I hit edit component. I am, right now, I am in part mode. Even though it looks like I'm in an assembly, I am actually modifying this part, which is kind of nice, and you'll see. I don't like how these are. It does this by default, and I don't like how those are transparency. I'm going to turn this on, and I'm going to say I want those to be opaque, or I want to be able to see what the hell is going on. Now, just going to say it again. We're in part mode, edit part mode, even though we're in an assembly. I'll jump back to assembly mode. I just hit this button here. I'm back in assembly mode. I click on it. I hit edit component in an assembly. So what I'm going to do is I'm going to create a sketch on that face. I'm going to put in a circle, just right in the, I'm going to put in a hole, just right in the middle. And I'm going to make the hole zero point 0.5 for the time being. And I'm going to make it line up with this origin. And I'm going to make it 0.75. I'm just playing right here, just getting a feel for it. Make sure you stay in part mode and you don't jump out of it. And I'm just going to extrude this through all. And let's have a look. I'm going to jump out of part mode and I'm going to rotate this knob. And I'm going to mate this knob with the hole. Like so. And I'm going to give myself a little bit of space from here to here because I might need some washers and stuff in there. Give myself, let's get back into, come on now, stop this messing. I'm going to get back into inches. So I make sure I'm in assembly mode. That's where people are going to get confused how I'm jumping back and forth. I'm going to make this 0.125, which is an eighth of an inch, which is just kind of a clearance for the time being. Now, and then I'm going to mate this worm with this face. And I'm going to pull this in here like that. And I can start to see that I can start to see that I'm interfering right away. Like so. You see that? So obviously that's not good. Okay. And let's put the shaft in while we're at it. Let's just section it. I know I'm moving fast. But anyway, okay. Let's okay. We got that. Stop, get out of this, will you? Now I'm just thinking, where am I going to how am I going to get this how am I going to fit this gear in? This gear is going to have to sit like something like that. And it's going to have to be a lot higher. Okay. Our wall thickness. What is our wall thickness? I bet you that's like a half an inch. So let's go back to McMaster car and get slightly longer bushings. Plain bearings. Shaft diameter is 1/2 inch. The length, let's make it, if we have a 1/2 inch, yeah, a 1/2 inch. Forgive me for a sec, I'm trying to think here. It's just a 1/2 inch, but we also have the lip. Let's make it 5/16, 5/8. We want the flange. What's the cheapest one? They're all cheap. High load, oil embedded flange. Totally overkill for what we're doing, but will do the job. It's only $1.25. Let's bring that in here. All right. Now, give me a sec. I'm going to take a break here just for a second. A cup of tea. Right. So, um, I'm I definitely need to increase the height of this. So I'm going to right click on it. I'm going to edit the components again. Let's look and see which it's this feature. So instead of me going back to the part and raising the height and then rebuilding the model, I can just do it here. So let's bump this up 2.5. There we go. Something like that. And I need to know, I need to go back to McMaster-Carr and find out what are the heights between the worm center axis and the worm gear center axis. So let me have a look at that. So if I go worm gears and the gear pitch is, which one now? We said the worm is a 1/2 inch. Now if I go to product detail, if the pitch is 12 and I want to find out what is the height, is there let's see if I can figure this out. These worms are compatible with plastic worm gears. So here we go. They're all in metric. Okay, let's go back here and let's go to the gear. I think our gear pitch was 12, was it? I can't remember which one we went with. Hold on a second. What is this one? It's K511. K511, alright. Now I need to know the pitch diameter is, it's 1.5 inches. So is that the distance? Is that the distance? No. Okay, I need to add it's 7.5 is half of that, plus whatever the pitch diameter of the worm is. I'm gonna have to write that down, my head's melted. So it's 0.75 plus, so let's go back. It's this pitch diameter here, and then I'm gonna need the pitch of the worm. The pitch diameter is 1 inch, so it's going to be 0.75 plus a 1/2 inch, which is 1.25. So that's my that is the distance between the two. That is the center to center distance between the two shafts. Okay, I'm going to right click. I'm going to create a sketch on this guy, and I'm going to draw a circle, and I'm going to change this so I can see this. There we go. Now watch this. Let's jump out of all of it. I'm going to right click on this and I'm going to go isolate. I just want to look at this guy within the assembly. And I'm going to click on it again, edit it. I'm going to create a sketch. I'm going to turn on the dash lines. All right, so I'm going to what did I say? An inch and a quarter is what I need. So I'm just going to go center line from there to there, and center line from here to here. Yeah, and then I'm going to do a little center line from the midpoint. Yeah, just like that. There's probably better ways of doing it. Now, why is this? What's going on here? Why is? Do I have two sketches? Ah, that kind of sucks. All right, I'm just going to delete this sketch and let's go back to this. I want to put a relation between this hole and that hole. Can I just pick up that center point? No. Let's just do this then. Come on. If you're watching this in America, you better be going out. I hope you go out and vote now on the. Is it the 5th? So anyway, look, point one 1.25, and let's put it, line it up with that vertical, and let's make it a half an inch. Make it a half an inch. Is it a half an inch? It's probably bigger because the bushing is bigger. But anyway, look, it'll do the job for the time being. Now, I'm going to turn back on the shading, and let's cut a hole there. Now, I'm back in assembly mode. I click the part, edit the part, I click the sketch, and I'm going to go extrude cut all the way through. All right. I'm going to exit out of the part. I'm back in assembly mode, and I'm going to hit exit isolate, and my part should jump back out. Look at that. Now, I'm going to click on, I'm going to open up this shaft. Ah, no, don't be like that. I'm going to save it first of all. Let's call this, if I click on it very slowly, the option to rename components on the tree's current off. Okay, to turn it on, go to Tools, Options, Feature Manager. All right, Tools. I can just, how do I get to options here without, I don't know if you can see this bloody thing. This is the top of my screen. Tools, Options, Feature, is it Feature Manager? Allow component files to be renamed from the Feature Manager 3. What am I doing? I'm clicking it once and I'm clicking it again kind of slowly. And I'm going to call that zero point 0.5 input shaft. And I'm going to hit save. And it should rename that. Don't worry about that, just go okay. Alright. I'm going to minimize this, minimize that, get this out of the way, gearbox idea, and I'm going to look at these parts here for a second. I don't need, is that the assembly? I called it gearbox housing. I should have called it gearboxes. Now hold on, let me just delete the, where is the shaft? Did it overwrite the shaft? Yeah, that's just fine. I'm gonna click on the half an inch input shaft, and I'm gonna control C and control V, and I'm just gonna right click on this, and I'm going to rename it, and I'm gonna call this output shaft. So let's go back here, insert components, let's put the output shaft in. Now I've got two of them. I have an input shaft and I have an output shaft. And I'm going to mate the output shaft with that. And I'm just going to stick this out. And I'm going to, yeah, let's do this. I click the input output shaft. Is it lovely? Look at that. The front plane has been mid planed. I'm going to lock this in like that and I'm going to center it. So I selected the right plane. I selected the front plane of the of the shaft, and I'm going to go mate, and that will center that shaft up. Now I'm going to mate this guy, the worm gear, with the shaft. And what am I going to do here? If I click on that worm gear and I look at the front, see the front is not exactly where I want it. If I right click on this and I go open part, I'm going to put myself in a plane here that I'm going to use. So I'm in the part now, and I'm going to put in a plane, and I'm going to click this face and that face, and I have a nice plane that's at the center of the worm gear teeth. I'm going to save it, I'm going to exit out, and I'm going to use that. So I'm going to use this plane that I just made. I'm in assembly mode, and I'm going to mate it to that plane, and I'm going to go mate. And I'm going to take a section view, and I'm going to have a look at the teeth. Beautiful. Yeah, that looks bang on. Now, what's the problem? The problem is the wall height needs to come up and the bottom shaft needs to come up. And I need to make the holes bigger for the bushings. Let's get rid of this bushing here and let's bring in the other bushing. Insert component. Let's bring both of them in. I don't know which one it is. That's our boy anyway there now. We don't want that. Okay. Um, Now I'm going to go evaluate, measure, and let's see what size this is. 0.625. Oh, the diameter is 0.75. Okay. I'm going to right click here. Well, let's bring this wall up. Let's do a section view of this. And this is where it starts to get powerful. I'm going to I'm going to click on the housing. I'm going to go edit component. And let's increase the housing height a little bit. And let's make it 4 inches, which isn't very high, but that's okay. 4 inches. And let's change this height. And let's make this 1.25. Let's see what that looks like. Let's jump out of it. And because I changed that and all of the dimensions are kind of locked in with each other, let's just rebuild this and see what happens. Now why? Okay, it must have had to rebuild. I'm gonna hit section view and let's look at this. Now that height is good. And this height is good, but this needs to come down a little bit by maybe oh, I don't know, half an inch. So we'll click on the housing again, edit component. People would say I might be jumping back. This is how I design. I don't know how else you might. There's prob there. I don't know. I don't know. There's different ways. Okay, beautiful. All right, that's that done. And let's now I'm going to right click on this. I'm going to go isolate and I'm going to edit these holes and let's make this 0.75. If when you 3D print this and you have your bushings, those bushings should take a little bit of effort to press in, and once you press them in they should be kind of stuck in there. If it's too slack and let's say it's not tight enough, well then you're going to 3D print this again and you're going to take about 10 thousandths of an inch, 0.01 of an inch. You're going to have to make those holes slightly smaller is what I'm trying to say. So let's click on this guy, and I'm going to hit press Control C, Control. What's going on here? Relax now. I click on it, Control C, Control V, Control V, Control V. I'm going to highlight them all and the housing, and I'm going to go isolate. So this is what you're going to have in real life, and you're going to mate this guy with that, and you're going to mate this with that. Look, what I'm trying to do is give every group a little gearbox that they can disassemble quite easily and reassemble and just see what the hell is going on. What is the function of a bushing? What is the function of a shaft? And the best way to do it is just getting your hands on it, in my opinion. We're up to 40 minutes. Alright, and let's mate this with that. Look, anyone that has a 3D printer at home, and I suspect a lot of you probably do, you can buy a relatively nice one for $150. An Ender 3. Now, there's my housing with all the bushings being pressed in. So let's exit the isolate and let's have a look at this thing. Now, we have our shafts. Now, how are all these things going to attach? So we're going to 3D print these parts. The only things we're not going to 3D print are the shafts and the bushings. So let's open this up. This guy, I'm opening it up. No, don't be doing that. Don't go crazy now on me. Look, my brain, I'm gonna click on it and I'm gonna actually edit it away from the, because my brain's kind of melted today. I'm gonna open it up and it's a shame I can't. It's that button there. Can I just move? There you go. You probably don't even see that thing, but anyway, open part. And what I'm going to do is I'm going to cut a hole in this hub on both sides, and I'm going to put in a quarter 20 screw to clamp it to the shaft. Now I'm going to click a sketch, and I'm going to just drill a little hole somewhere like that, and I'm going to line it up horizontally with that origin. Is it going to let me do that? Line that up there with that. Coincident, and let's maybe make this 0.25. What's that look like? That's fine. 0.25. We could bring it over a little bit. 0.3. That's just fine. And I'm going to make this zero point 0.2 of an inch. The reason I'm making it zero point 0.2 of an inch is I'm going to go in there with a tap, and I'm going to tap it out. I'm going to tap material in there. The 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 tap size for a quarter 20 screw is zero point 0.2. So anyway, trust me, zero point 0.2 of an inch. The rest of you that are doing this in Madagascar or Donegal or wherever the hell you're doing it in, you can you'll do it in metric. You're gonna have to figure that out. No, but I'm gonna extrude that through all, and did it do it? I only did it on one side. Let's do it through all on both sides. All right, there you go. So we're gonna have a screw going through that to clamp it to the shaft. Now, what's stopping this guy from? What's stopping this shaft from sliding in and out like it would? I'm going to have some clamps, some little shaft collars on either side. Okay, we'll worry about that later. So let's look at this and this, and we'll isolate that. I'm going to change the design on this gear, and I'm going to give it a hub, its own hub. And I'm going to open it up because I couldn't be arsed editing it. I want to open it up by itself so I can kind of look at it clearly. And I'm going to create a sketch on here, and I'm going to click this outer circle. Now let's just redraw it. So from there to there, let's not forget the keyway. One, I'm holding down the control key now, and I'm just going to go convert entities, and I'm going to trim it. You bollocks. Can I undo? What the hell? Let's try it again. One, two, three, four, five. I'm holding down the control key, convert entities, then I'll trim it, and now I have that. Now, why do I need to put a dimension on this? Let's just leave that, whatever it is 0.81. Let's extrude, exit, extrude. Let's make it point 0.25 maybe. No, but let's make it a bit more. 0.5. That's good enough. Now, instead of having this keyway, I'd like to get rid of that keyway and just clamp it with the bloody set screw. So let's just have the set screw clamp it. I could always clamp it from the other side. Let's just do it there. Right plane, sketch. We'll do the same again. I'm going to draw a circle. I'm going to make it zero point 0.2 of an inch. If you don't know where I'm getting that 0.2 of an inch, look at a drill tap chart for imperial dimensions, and you'll see exactly where I'm getting the 0.2. Look at a drill tap chart for a quarter 20 screw. We make sure our sketches are fully defined. Let's make this 0.25. Perfect. And I'm going to go extrude cut, and I'm going to go through all, both, like there. Is that enough wall thickness? Close enough. It's not like it's driving anything. If you want it to be anal, you could make this wall thickness bigger. Let's do it. Let's do it. While we're at, let's make it one. Yeah. Now, but if we make it one, am I going to screw up those threads? Let's make it 0.9 even, and we'll look. We're gonna have a big gap there. If I go extrude in one direction and then I go in the other direction, and I'm going to make it up to next, and I don't think that's going to affect. No, I don't like that. I don't like this. I don't think that's going to interfere, is it? Why did it just stop there? Up to next. Forgive me just for a second. Like, why don't I just, if I just bring it in, it's going to mess up those threads right there. Um, why isn't that working? Up to next. Body. Doesn't work very well. Just leave that. I don't like this here. See, that's nasty. Yeah, I'm getting tired. I couldn't be arsed dealing with these details right now just for this part. Um, just forgive me for a second. I don't think that's going to be a problem. You'll find if it starts binding down here at the end, you're going to have to redesign that worm a little bit. Okay, And now we have something to tap a little set screw into. Let's exit isolate and let's have a look. And this guy's moving up and down. Right, how do we line this up? I'm going to do a section view. Like, I'm just eyeballing that there, but how do you do it? I'm guessing you get, if I open up that worm drive and I go with that top plane, I bet you that top plane should line up with that. So if we go top plane and we align it with the front plane of the housing and we line that up there like that, that's perfectly lined up. Now, will I be able to access that screw if I want to? Yeah, I can access that screw with a driver. I'd have to just pull that shaft out. Now this guy is not going to move. Well, that shaft could move, and this shaft we gotta stop them shafts. We gotta lock them in actually. Now, the gears are going to attach to the shafts. Okay, I'm going to open this up and do the same with this. Open, and I'm going to go front plane sketch. I'm going to get myself a point 0.2 hole. I'm going to line it up with this origin horizontal. Okay, lovely job. That's all right. Let's make this point 0.4. That'll do. That'll do just fine. Well, where's the hole? How deep does the hole go? Let's find out. Yeah, we could make this point 0.3, 0.35. There we go, and it'll just nicely attach to that D shape on the shaft. And I click on the sketch. I'm going to go extrude cut. Boom. And now I got two holes. Save. Now I'm lazy and I wouldn't bother even putting in the hardware for that, but hopefully you understand that I'm going to use a 1/4 20 screw. I'm going to tap these holes and then I'm going to put the 1/4 20 screw through that to attach this to the shaft. Now that's going to attach that to the shaft, and this knob is going to butt up against that bushing, which is just fine. And I'm going to have to come around here and I'm going to have to put a shaft collar on that. I'm going to have to put a shaft collar on either ones. And I think that's enough. That'll restrict the shaft. So let's have a look. Shaft collar, and I want it to be for a 1/2 inch. I just want I just want a simple one like that. I don't even need a keyway. It'll be for a D profile. I don't need this fancy split one. Is there not a split one? That's kind of that's crazy money. I just want a really simple shaft collar, and I don't want a clamping one. A set screw shaft collar for 1/2 inch. $2 will do the job. Done, done. Let's put this in our folder first. Look, my students, you guys are rough with file management. I don't know what else to say. Stop. Critical to have manners on it. I just want to make sure I've got no different parts here. All right, let's go insert component. Set screw shaft collar. I'm going to hit the pin. I'm going to put one here. I'm going to put one there, and I'm going to put one there. I'm going to press escape. And I'm going to put a shaft collar in to right there. You're going to have a little bit of friction between that and here, but this is made out of bronze and that's made out of steel. It's going to be pretty low. There's things you can do to minimize that. If we were using bearings, look at bearings with an inner raceway that protrudes. They're just expensive. That's what I was originally looking at. Something like that. And what's nice about this little assembly is they're going to understand what shaft collars do. They're going to understand what bearings do. They're going to bushings. They're going to understand what shafts do and gears. There's a lot going on here. Now, is there anything we're missing here? All we're doing is we're missing our bloody hardware. Look, I'm lazy. Let's go set screw. No, not set screw. Screws. Socket head screws. Inch. 1/4 20. The reality is, you might even. No, I don't know if you could self tap the screw in. You might. Do we want a 1/2 inch? So we got to look at this. Let's take a section. Well, let's see this guy. If I bring this down, there could be two places where we might get interference. No, I think we got loads of clearance there. So let's get a screw and put it in. That's one place. Let's just leave that there. We want at least let's get our evaluate out and measure. Give me what length is that? That is zero point 0.2. So a length of 5/16 will work and give us a little bit extra. So let's go 5/16. Let's go save. Very expensive screws. Why are they so expensive? 50. So these are how much? $2 a piece. They're expensive. Just go with this. These are nearly one, a little bit over one, but anyway, these won't rust. Um, Open that up. It's tough having only one monitor. If I was building this and I wanted it to, if it was dealing with a proper load, like it was really doing real work, I wouldn't design it this way with just a set screw. We would definitely need something else, like a pin, or we would be using keyways, all of that. Now let's see how this works. Oh yeah, see, I'm glad we checked this out. Oh yeah, that might interfere. All right, let's have a look. We can find out. Just like a little tangent, mate. Oh yeah, this might interfere. Yeah, it will interfere. Look, boom. Do you see that? So let's get some set. We're gonna have to just get some set screws. Let's get rid of that. Let's delete him out of there. Hit save. Save all. Let me just take a quick 5 minute break. I'm going to get another cup of tea and I'm going to even do the exploded assembly. I'm really rough with them. Let's keep going. Now, I can't remember what we were doing. We were putting set screws in this thing. And I'm just thinking, yeah, we're going to put set screws in this thing. We're going to change the design a little bit of the box. And then we're going to create an exploded assembly with the installation instructions. Now, let me just look at this for a second. Is there anything I'm missing? Set screws. And that's it. We turn this. Do we have enough clearance? Yeah, we got loads of clearance there. Yeah. And everything's going to hold in place. Yeah. Could probably make that shaft a little bit longer. Now, so let's go back here. Set screws, and we want a quarter 20. Whenever you're designing anything for what, a quarter of an inch, I would think, of length. And yeah, do we want? I would think a nice hex, and I would think a flat is what we want. What's the cheapest ones? God, there's loads there. Extended soft flat. Yeah, just fine right there. Whenever you're doing threads and 3D printed materials, you want a pretty coarse thread. If it's too fine, it will just rip through. Now, I hate when we have extra parts in here that I don't need. I got the input output shaft. If I delete this, is it going to let me delete it? Yeah. I need this, I need that. I don't need this anymore, it won't let me do it. Okay, that's fine. Insert components. Where's my set screw? No, no. There you go. Is it smart? No. Usually I've seen them where they will actually, they're smart enough that it will actually install it, but that's fine. Let's hit the pin. I'm gonna have one, two, and I can do them from either side. So I'm gonna have six of them. But I'm gonna put in I'm only gonna put in three. Because I'm lazy. Mate. No, you gotta, it's kinda hard to pick which face it is. It's this face right here is what you need to pick. That's the concentric one. No, I want that to be, it won't, I'm wrong. Let's try it again. I always thought it was that face there is the one that I use. No, let's try it again. Maybe it's actually this one. Let's try that one there. There she goes. And let's flip it. Is it the other way around? There she goes. Alright. And I'm gonna pull this out. I'm gonna mate the flat section to there and to there. And what that will do is it will lock the handle to the shaft. Let's do the same with that. Is that the right way though? There we go. Let's pull that out. Let's press Control Z. I think I pulled that out too much. There you go. Let's pull it out a little bit more. Look, this is where the isolate works. If I click on this guy and that and this and go isolate, it makes it easier to see what's going on. Mate, I isolate the wrong parts. I need this, that, and this. Isolate. Alright, now you go from there to there. Oh, will you look at that? Made in America. And look, if you want to go overkill, you can put one in the other side. And that will lock all of that. And then I'm going to go from here over to this guy. And is it the right way? I'm going to flip it. Yeah. And the beauty is if I go, you you are going to mate to the flat one. Watch this. If I turn this shaft and now I turn this shaft, What I need to do is I could create, let's just do a section view and kind of get this lined up, kind of like so. And you stop now. Hold on, hold on. All right, I'm gonna go mate, and I'm gonna go mechanical gear, and I'm gonna click on one shaft, and I'm gonna click on the other shaft, and the ratio is gonna be 20 to 1. And let's see what happens. Too fast. All right. So it's 1 to 20. So let's go back. Now, where did I get the 20 from? I'm pretty sure that's 20 teeth. 1 to 20. And now, if I turn that, is it going the wrong way? Yeah, it is going the wrong way. All right, let's go back. Going in the opposite direction. What do we do? Reverse. Okay. Now I'll right click on this lad. Look, do we like that the way it is? Do we want to change it? Um, Take any of those. They're right there. Is that right? Is that doing it? Yeah, that's the way it is. Now, I'd love if we could print this with PLA that's clear. So I'm just going to open this up. It's kind of boring, isn't it? What happens if I put little fillets on it? Full preview. There's only so much you can do with a little box. Just break the edges on it. Do that first. And then I'll put another fillet in. Just like that. That's good enough. That's pretty much all we can do. Alright. Like it. That's it. That should work. Shouldn't be any issues. I'm going to save it. I'm going to create a drawing to make my life easier when I'm going to get my students to do this for me. I'm just making sure that knob is nowhere near the deck. Now, I'm going to go file, new, come on now, drawing. I'm going to go size B. Come on now, be good. All right. I don't like all this nonsense. Let's go edit sheet format. Let's get rid of all of this bollocks. All right, that's better. And I'm going to I place the view. I'm going to get myself a section view. Something like that. I'm just looking at this. Yeah. Let's make that solid. There you go. Let's make this solid. Okay. This a bit bigger. Make that 0.5. I'm just picking a number out of my head. And that's just fine. And if I go projected view for this over, And what happens if I do a section view here? I'll right click on that and I'm going to go alignment, break alignment. Just put that down there. And I'm going to go insert tables, bill of materials. I can pick any one I want, it doesn't matter. I'm just going to go OK. And this should have everything. Now, I'm going to change some of this. Break link, 3D print. Now, what is that 511? If I, okay, watch this. I'm going to go edit sheet format and let's just get rid of all of this. Look, I just need something to help me build this thing. There you go. And I'm going to get some balloons. Now, where's our balloons? There you go. Now, one, two, three, four, five. Now, what are we missing here? Four, five. One, two, three, four. Four and six. All right. Six. Look, any half an inch shot will do the job for this. Now, what is 511? 511 is, look, let's just leave it, the part numbers the way they are. The metal worm. Can I press Control C and Control V? Break link. Oh, I love it. The knob, we're going to do the same. Break link. The gearbox housing. Ah, shut up with your stuff. Yeah, we need the shaft collars. The rest we're going to order. Now, if I go 511, now what's 511 is the worm, isn't it? The worm gear. There we go. Oh man, there was a time I used to do drones all day long. Bored the crap out of me. Oh, alright. If I hit this top corner and I go formatting row height, and it's in bloody millimeters, let's make it 9 millimeters. That'll do. Why didn't you just stay in Imperial and make life easy for the rest of us? 3D print. To say such a thing on the internet. Come on now. It's not the worm gear. Okay, what is K48? Which is item number 3, which is the knob. Now, we're going to 3D print the housing. We're going to 3D print the knob. We're going to 3D print the worm gear. We're going to 3D print the worm. And we're going to order the rest of it. That's it. Is there anything else? Let's save that. And we just save it like that. Let's have a look at it one last time. Yeah, I think I think we can make that. Is there anything else I could change on that? Would we want the worm on top of the worm gear so we could see it? Or I think that's the way to go. Yeah. Yeah, look, that'll have to do. It's good enough. What would they do? They're going to have to unscrew that, untighten that, take the knob off, take that off. They'll be able to drag the shaft all the way out. Yeah, they'll be able to disassemble the whole thing and reassemble it quite easily. Look, that's it. Look, hope everyone's doing well and you got something out of it. I'll see you later.